Now we continue from where we stop, where we said we are continuing from volume 3. So which volume 3 was in the volume 3? Let's go with that. So we have in volume 3 the interpretation. So after we have done the analysis on SPSS, the next thing we have to do is the interpretation, and we got to know that the old version of the SPSS has an auto generates your interpretation for you, which is the version, the 11th version, that's SPSS version 11.0. This one is the latest version, which is 27.0. So the old version has an auto interpretation on it, so but probably we're going with the interpretation of this, so you just need to do it together. So, and you have the old version, and I will encourage, if you want to use the old version, maybe you want to use it for something else, but the latest version, the latest SPSS version, maybe you are probably using it for work, or maybe for your business. You can use the latest version and interpret either with the AI, or you know how to interpret very well, you can use that. So but for now we'll be going through on how to interpret. So the first one is how to interpret SPSS output. SPSS is just to analyze for you. You are the one to interpret, as the case may be. For the latest version, you are the one to interpret. So and the second one we're going under interpretation is one-page cheat sheet for SPSS output interpretation. So let's move on. How to interpret SPSS, the first one. So the simple guide for everyone. What does interpretation mean? Interpretation, that's after running analysis, SPSS give us tables and number, charts, and everything we need to know, the ANOVA, the model, the correlation we have, and everything. So we are the one to interpret. So interpretation really means that, okay, the output that we have been given, what does it mean? We are the one to interpret. If you are working for a business, you are the one to interpret what it really matters, as what we have done earlier on our SPSS, which we've done the total mark, and what we want to interpret there is just like, okay, maybe the class average, or the highest mark, like set of people with the highest mark in the class, and a lot of that. So you see, important idea. SPSS does the calculation, we explain the results. So that's for the A part, and we have for the B part. Okay, these are the first 5 questions to ask after any SPSS output. Like now, when SPSS give you the output, you are now led to ask yourself, oh, what's the next thing to do? So which test did I run? You said, okay, which test did I run? You run and for this one I run descriptive statistics test, and you might run maybe analysis on, maybe you run correlation and regression and a lot of that. Maybe probably you want to do more things like maybe the collinearity and multicollinearity and everything like that. So you do the test. Which variable am I involved in? Which variable are involved? Maybe the variable involved is the total mark gender for my own for the one that we use, for example, under when we are touring with the second volume. So is the result significant? That's for maybe you have the correlation and regression, and you have the p-value, which is almost 0.05 for statistics, and most maybe for social science or other departments they use 0.01 in most cases. So what does this mean in real life? That's when you are dealing with business or other stuff, like, and you are analyzing for them and you want to interpret what you have got. So if this answer, the interpretation will be correct. So let's move on. We have the main interpretation part. Which is first one, interpreting descriptive statistics, and you interpret the table that you have, okay, and interpret with the, okay, for descriptive mostly, so you interpret the frequency, which is the gender. So here is the gender, we have the gender you interpret, okay, the number of students, the number of respondents, which is male with the highest number of participants, and we have female, and the least participant I prefer not to say, which is, you can interpret this space as male having the highest number of respondents, and with the percent of this, you just interpret in that way. So it's just like you are telling what people need to know about the table that the output's already given out. So next one, let's be fast. So the average, like now what we have just said, maybe this is the B part we've done for the percentage, for frequency, sorry. Maybe we have the gender satisfaction, another category is student ID and agent and the gender, and we just interpret for the gender now. And we are going to the mean and standard deviation, which are the numerical. We find the average and standard deviation and we interpret. Let's check the interpretation to what we've gotten here. So here is it. So you just interpret, okay. Yeah, here is it. You just interpret this table that, okay, we have the mean value, the mean for this, we have the mean for the student ID to be 8.0 and the mean for this general respondent to be 1.3, and you just interpret with that. Okay, this is what we got for, and the total mark we got 22.4. We just interpret the standard error and mean median, the mode, the standard deviation, and we brought out skewness and kurtosis here, so you interpret that one too. So interpretation is not that hard when you know the concept. So interpreting relationship. So correlation. What's the correlation? Correlation is just the measurement, the measure of the strength and direction of linear relationship between two variables. Like, okay, we are dealing with the measure of correlation between the total mark and maybe the gender. Let's do it that way, or you can do the correlation between that. So we just we said is the measure of strength and the direction. And before you proceed, if you want to interpret, you maybe probably you have the correlation coefficient, which is the R, the small r. Because we did not analyze for correlation here, I don't need to show the table. So you find the absolute value, which is just like the determinant of a matrix. We find the absolute value, which is you remove the negative sign for when you want to write it. But if you want to interpret, you interpret with respect with the negation that you have it. So here we have the R to be negative sign of 0.68, and we interpret there is a strong negative relationship between the study hour and stress. And probably if you have a negative correlation for maybe the student and the total the gender and can we say the gender and the, I don't think we can still do the correlation with the table that we got with the with this that we work on. We can still do the correlation with the level of study and the gender here. So we can do correlation with this. So let's proceed. So you find the first thing you just need to do for interpretation of correlation is find the absolute value and then interpret. So why absolute value? Because the strength matter more than direction. When you find the absolute value, you know the direction to be a negative relationship, but the strength, so is the R. When you find the absolute value is the strength. So interpreting the group difference, that's a t-test and ANOVA. So t-test, that's two group. When you have two group mean, so and the p-value, most cases we said it is 0.05 for statistician, and maybe for social sciences they have it to be 0.01. This statistics significant difference between male and female students. Like, okay, we want to do the statistical difference between the female and male students. We can do it when p is less than 0.5. There is a when p is less than 0.05, there is statistically significant. There is a statistically significant difference between the male and female. If you want to do the um, t-test of the two groups, which you have the male and female students. So we have for ANOVA, when you have two to three and three or more groups, that's when you have two groups, that's when you do for t-test, and when you have three or more groups, that's for ANOVA. When we have, that's when we do for three or more groups. For ANOVA, we do for three or more groups. So we look for the F value and P value and interpret. So the mark differs across the satisfaction level. Like, okay, we are doing it for three or more groups. So no absolute value used. So for interpreting of regression, so if you want to interpret regression, what's a regression? Regression is the model, like this models the relationship between variables, and it's used for predicting a continuous outcome. You want to predict, maybe you are dealing with height and weight. You want to predict weight based on the height, or you want to predict the price of something to the to a effect. Now, regression explain which variable affects the another. Maybe the variable, the dependent variable, it is affected by the independent variable. So how strong is the effect? And the interpretation will be, the signs is the direction of the effect, and we have the absolute value to be strength of the effect. So when we want to interpret, you said it's the stress negative effect. The negative will also occur, but you will find the absolute value before you interpret. Stress negatively affect the marks, and the effect is strong with this value. You put the value of the beta. So the beta. So let's go to collinearity and multicollinearity. Is also very important too. So when independent variables are related to each other, when you have two predictor, so that's when you have two or more, predictor, you can have two predictor. When you have two or more predictor, that's when you go for multicollinearity. For collinearity is just with two predictor, and multicollinearity is with multiple predictor. This check on regression analysis, you can do that on regression analysis. You have probably the predictor, which is the independent variable, and outcome, which is the dependent variable. So when you have two or more independent variables, that's when you check for collinearity and multicollinearity. So let's move on. But collinearity and multicollinearity are useful when you have two or more predictor, that's consecutively collinearity and multicollinearity. So where to find collinearity in SPSS is just go to, if you want to check for, when you have for, you go to analysis, regression and linear. You go to analysis, you go regression, and you check on linear. That's when you find it, because we are not doing anything like collinearity here. So that's how to check here. If you are told to check for collinearity, or you want to check the collinearity, if you have a data which has two predictor, so that's how to check for the collinearity and multicollinearity. So where to find collinearity, I think we have done that. So it provide the SPSS provide the tolerance and variance inflation factor. How to interpret the tolerance and variance inflation factor. So the tolerance, the value interpretation, as when you have it to be less than 0.2, there is no problem with the tolerance, and when you have it to be less than, when you have it to be greater than or equals to, when you have it to be greater than 20, there's no problem. Like when you have it to be 30, there's no problem. But when you have it to be less than or equals to 20, there's possible multicollinearity. But when you have it to be less than 10, 0.10, when it is less than that, that has a serious multicollinearity. So if you have 30, when your value for your tolerance is maybe is 30, 0.3, I'm just saying 30, 0.3 or 0.25, there's no problem with the multicollinearity or collinearity. But if it is less than 2.0, that's possible, is still possible. But when you have it to be less than 10, that's less than 0.1, than serious multicollinearity or serious collinearity. So the interpretation when it is less than no for value variance inflation factor, the value interpretation will be when it is this one is when it is less than 5. When it is less than 5, this one is when it is greater than 0.2 for variance inflation factor. When it is less than 5, no multicollinearity. 5 to 10, that's moderate multicollinearity, and if it is greater than 10, that's serious multicollinearity. Just the vice versa for the tolerance and the multicollinearity for variance inflation factor. So you can focus on that. It is easier how to write and interpret multicollinearity. No multicollinearity. If you have no multicollinearity, the variance inflation factor value of all predictor were below 5, indicating no multicollinearity. You see how they interpret shortly. So for case 2 now, when the multicollinearity is present, some predictor shows that high variance inflation factor, which is the value is less than 10, indicating the presence of is greater than 10, sorry, indicating the presence of multicollinearity. Therefore, the regression result should be interpreted with caution. In most cases, you don't have multicollinearity in what you are analyzing. So let's go straight to number 9. Why multicollinearity is a problem? Explain. Like, it does not affect the overall prediction, but it confuses individual predictor effect, but values become unreliable. The value that you got to the beta value become unreliable. The beta value and the regression aspects become unreliable. You won't rely on your beta. So SPSS cannot clearly separate the effect of predictor. So we have the absolute value of multicollinearity. Do not rely on beta when multicollinearity exists. So beta value may look strong, but are distorted due to overlap. Always check your variance inflation factor first, then interpret the beta value that you got. We're going to use the absolute value. So the absolute value now is on correlation, regression, and maybe the factor loading. That's when you want to check for multicollinearity. Most cases don't need it in multicollinearity. So most cases you'll be needing it under correlation and regression. That's when you do. For correlation, you check the absolute value of your correlation coefficient, and regression beta, you check for the absolute of the beta. So do not use the absolute value when you are doing mean, standard deviation, and p-value and variance inflation factor. So this is the chart. So when you got the output, what to look at is the percentage for frequency, the average for mean value, and the correlation. That's when you check for absolute value. The only two spaces that you'll be checking for the absolute value is the correlation coefficient and the regression beta. So let's move on. I think, okay, the chart, the number 12 shows the chart. One line master, just a line master. Sign shows direction, absolute value shows strength, the p-value shows significance, and the variance selection factor shows the multicollinearity. So check this. Now this is just a interpretation for a general analysis of SPSS. The analysis conducted using SPSS, the result shows a statistic similar effect which the p-value is less than, although the relation is positive or negative, probably depending on the relationship of what you are correlating, like the correlation relationship of the variables, or of the variables, or the absolute value indicate a strong effect, and the variance inflation value were below the accepted limit, indicate no multicollinearity. And when you have the presence of multicollinearity, you also say so that we have the presence of multicollinearity. So here is the cheat sheet. So you can check the first two. Always